So, welcome students for this foundation class. I again repeat the objective of this foundation class is to make you more equipped in ninth and 10th standard syllabus, so that when you take up actual coaching for NEET or JEE or CUET, you will be in a better position, because many of the fundamentals you learn from in the previous classes. So that is 9th, 10th, 8th, like that. So that is the purpose of this foundation class. And many a times our foundations are may not be as strong as we think. Foundations could be little weak. So we wanted to make that foundation strengthened. So that is the reason it is called foundation class. Straight some questions from what we learn in this class may not come in your NEET and JEE, but then understanding these things will help you to learn 11th and 12th syllabus in a better way, and then probably you are more equipped to answer those questions. So is that agreed? Is that understood? Yeah. So now we are going to talk about a chapter called solutions. Have you heard of this? Have they covered this chapter solutions in your school? Solutions? Not in 10th, maybe ninth or 10th.
Yes, sir.
Yeah, somewhere you must have studied. Say, I don't know. Say, I'm not a typical teacher, so I don't know whether it comes in ninth or 10th and which chapter. All these things I don't know. But these are some of the fundamentals. So, okay, solution. What is meant by a solution? It is a homogeneous mixture of two or more substances. Component present in lesser amount by weight is solute. So, in a solution, it is a mixture of two or more substances. One substance is called as a solute, the other substance is called solvent. A typical solution, there will be two, one is a solute, other one is a solvent. In a salt and water, that combination, salt may be a salt water, salt may be the solute, because the quantity present in that solution is less. Water may be solvent. Am I correct? Hello? Am I correct?
Sir.
Okay. True solution is a mixture that contains small solute substances. Sugar in water, salt in water, that is called true solution, because you have put some small solute in that solute substances in that solvent, and then that dissolves that solute. Solvent dissolves the solute and becomes a solution. A solvent dissolves a solute and becomes a solution. Agreed?
Yes, sir.
Yeah, so colloidal is no, I'm just talking about various terms. Colloidal is a heterogeneous mixture made up of two phases, namely dispersed phase and dispersion medium. That dispersion medium is called solvent. Maybe the dispersed phase you can equivalent to solute, you can call it. Colloidal is a heterogeneous mixture. It is not a homogeneous mixture. It means it does not dissolve in the entire solvent. It does not dissolve uniformly. In some places it dissolves more, in some places it dissolves less. So colloidal is a heterogeneous mixture made up of two phases, namely dispersed phase and dispersion phase. Okay. Milk. Milk is a liquid in liquid. Cheese is solid in liquid. Smoke, solid in gas. Smoke is a colloidal mixture. So solid in gas is a blood, liquid in liquid. That is, in blood you have that blood particles as well as the water. Soda water, you are mixing gas in liquid. Here the liquid is the solvent and gas you can equate it to solute. Okay. In milk also, it is more of water and less of milk, that portion. That one. Okay. That is why it is a colloidal mixture, because it is not heterogeneous. It is not uniformly, it's not mixed. If you look at when your mother makes this one, buttermilk, क्या बोलता है, lassi, is it mixed very thoroughly? Or you will see some kind of something floating, small portions are floating, yes or no? Hello, when you make a buttermilk from your curd, so she stirs it, water is added, stirring goes on, but still it is not, does not dissolve completely. Very rarely it dissolves completely. Even if what we call it dissolve completely, you can see some of these, something floating here and there. Okay? Do you agree with me, children?
Yes, sir.
Yeah. Say for example, I'll tell you. In
Yes, sir.
all over the world, beer is produced in large quantities. Beer, drinking beer. And drinking beer, how do they produce? They mix that malt with so many other things, and the malt is a solid. A lot of liquid is there, and then a little bit of alcohol is added. Everything is added. It is stir, and then it's still kept on stirring. That vibrator or whatever, I don't know how are they doing that, they do, but still the beer. But when the beer comes in the bottle, it is crystal clear. But actual beer is not crystal clear. You can see some haze effect in the beer. Haze effect means that small solid particles will float on the beer. But we don't see that small particle, because the consumer thinks if there is a small particle floating on the beer, the consumer thinks the quality is bad. So the manufacturer, what he does is, he puts a material there, some material, to dissolve even that small particle, and that small powder which is put to dissolve that malt is called papain powder. It's called papain powder. Papain powder is, all of us have seen papaya. Have you seen papaya?
Yes, sir.
Yeah, in the papaya, in the green papaya, if you scratch the skin, do you get white milk? Do you get white milk when you scratch the skin of the papaya? Raw papaya?
Yes, sir.
That is called papaya latex. That
Sir.
latex is converted into powder, and that powder is put in the beer to dissolve that malt, so that the beer will look crystal clear, so that the customer thinks the quality is good. But actually, normally in ordinary beer, without using this papain powder, there will be some haze effect will be there. Okay? So that is called a colloidal mixture.
Excuse me, sir.
Yeah.
Sir, Abhinav's waiting it's him, sir.
Oh, sorry, Abhinav. See, once I go into the class, I forget all of you. That's my problem. What to do? Swastik, what should I do? I forget many things.
Don't know, sir.
I'm so involved sometimes, not all the times. You must have seen me, not all the times. I admit people, but sometimes I forget, even I forget myself. Sometimes now when we are involved in some activity. Suppose Swastik Swaran, let me deviate from the topic. Have you got an activity where you are involved, even if your mother calls, hey Swaran, Vada, come and take your coffee, even if she says 3 or 4 times, you don't get into the area, you don't listen to it.
Yes, sir.
Did you have such a situation in your life?
Yes, sir.
So what are those activities which you are so involved in those activities? What are those activities? Not only
Sir.
for Swastik, it is for everybody. Srinidhi, what are the activities you are involved? So focused, so concentrated. Even if your mother calls, Srinidhi, Vadi, when the coffee is ready, you take the coffee. She yelling, she yells. She keeps on calling. Still, you are not able to hear it. So what is that activity which you are involved so intensely? Yes, Abhinav, what is the activity you are involved so intensely, even if your father or grandmother or mother calls you, or grandfather calls you, you are not able to hear them? Did you get my point? Did you get my point? Students, did you get my point, what I am trying to say?
Yes,
Swastik,
sir.
are you getting my point?
Yes, sir.
Or Sachin, are you getting my point? Arshit, why you are keeping quiet, Arshit? See, I am saying you are involved in an activity, whatever be the activity, and your mother says, you come take coffee or take breakfast, etc. Still, you are not able to hear them. because you are so involved in an activity. What are those activities? I mean, it varies from person to person. Abhinav, what are such activities you can think of? Sachin, Srinidhi, Swastik, tell me, one of you at least.
Watching TV.
Watching TV, okay. Other than that, okay, that watching TV is a passive activity. It means you are not actively involved. Do you agree with me, Abhinav? You are not actively involved. It's a passive activity. But tell me an activity where you are involved actively and you are so focused and concentrated, even if your mother is calling 4 or 5 times, you are not able to hear her. It does not mean after hearing you are keeping quiet. Not that. You are not able to hear. You are so involved in it. Yes, Swastik wanted to say something. Reading books. Okay, what type of books, Abhinav? Now I am coming to the point. What type of books? Okay, watching TV, you leave it. Reading books, what type of books? All of you can say whatever no you are involved in it. So Abhinav said it was reading books. Definitely not textbook, I think. Is it textbook or some other book, Abhinav? Story books, sir, or some kind of fiction. Okay. So we are so involved in the story or in that fiction, we are not able to hear when our. So you all of you go and identify this particular thing, and that may be your passion. That may be the area which you wanted to do. If you do that kind of, if you take up that kind of activity as a career, you may excel. There's a possibility you may excel. You may do well. Understood? So here is an activity where you are so focused, and if you are able to identify those things, perhaps you may be, you are identifying your passion. What is my passion? We imagine ourselves in the situation, so we don't realize what is going on around us. Correct. That's right. Right. You are absolutely correct. Now you identify, not you need not tell here. Go and identify the activities where I am so involved. All of you. List down at least 2 or 3 and keep it with you. Don't share it to me. Keep it with you, and those things may be a passionate activity for you. Okay, that is away from our syllabus. Since okay, so I am just talking today solutions. We are going to look at some theory in science. Okay, this is a part of the science. Chemistry is also a part of the science. So solution is a homogeneous mixture of 2 or more. Are you able to see the screen, all of you? Are you able
Yes.
to?
Yes, sir.
People who have entered late, no? Okay. Solution is a mixture of 2 or more substances. Component present in lesser amount by weight is called solute, generally. True solution is a mixture that contains small solute substances. Say, for example, sugar in water or salt in water, all these things are called true solution because the substance quantity is very less normally, and then the solvent quantity will be more. Colloidal is a heterogeneous mixture made up of 2 phases. Colloidal heterogeneous, it is not a homogeneous mixture. It means it is not mixing uniformly in the same way everywhere. In a colloidal, in some places the mixture will be very dense. In some places it does not mix properly. So it has got 2 phases. One is called dispersed phase and the dispersion medium. The dispersion medium you can call it as solvent. I mean equivalent to solvent. Let me that cannot be called a solvent. I think it's equivalent to solvent. The dispersed phase you can call equivalent to that solute. For example, milk. Milk is the milk item, the milk product in water. So here the milk product is your solute, equivalent to solute, and that water is a liquid. So both are liquid in liquid. Cheese, solid in liquid. So here the solute is solid, solvent is liquid, so it is solid in liquid. Smoke is so solid in gas. So you can, in the smoke you can see some small particles are there, that is solid, and that it is actually getting dispersed in the dispersion media which is called gas. Blood is again, it's a liquid in liquid. Soda water is gas in liquid. Soda water, carbon dioxide gas is mixed with the liquid, and it is kept under tight, high pressure container, so that when you open it, it comes very fast outside. So soda water is gas in liquid. So when you talk about colloidal mixture, then you have to say what is solid in, whether it's solid in liquid or solid in gas or liquid in liquid, liquid in gas or gas in liquid. You have to should be able to say that, define that particular thing. Suspension is a heterogeneous mixture of small insoluble particles. Some powders does not dissolve. So it will be actually suspended. It may be there in the top floor of the, top surface of the liquid or the solvent. Like for example, if you put chalk powder, if you put in water, what will happen? It will be floating on the water. If you put chalk powder, will it be floating on the water? Hello?
Yes, sir.
Yeah, so
Yes,
it,
sir.
for the naked eye, it's floating on the water. So this is called suspension. It is again so what is meant by Tyndall effect? There is a term called Tyndall. We are going to see some of these bits and pieces, some of these information which you have studied in your school somewhere. I don't know. All these things have come in 9th standard or 8th standard or 10th standard. Which standard?
Ninth, sir. Ninth.
8th or 9th or whatever. Okay. Tyndall effect is a phenomenon by which colloidal particles scatter light. Tyndall effect is a phenomenon by which colloidal particles, it scatters light. Brownian motion. What is this Brownian motion? A phenomenon of continuous random motion of colloidal particles. This colloidal particle is always on the move, on the motion. So that motion is a continuous random motion of colloidal particles. That is called Brownian motion. Saturated. What is saturated solution? Where no more solute can be dissolved. Suppose you put a salt in a water, it get dissolved. Again you put some more salt, again it get dissolved. After some time, it does not dissolve the salt. So at that solution where no more solute can be dissolved is called saturated solution. Okay. Supersaturated solution is, even if the saturated solution, in saturated you cannot put more solute. But if you heat the saturated solution, if you give some heating, then it can dissolve some more solute. So that is called supersaturated solution, which has more solute at a given temperature than that of a saturated solution. Okay, so these are something which you need to keep in mind. Can I ask you, as one of you, to read this whole thing? Swastik, can you read it for the benefit of everybody?
Yes, sir.
Teresa, I mean, is it big enough to read?
Yes, sir.
Okay.
Solution: a homogeneous mixture of two or more substances, component present in lesser amount by weight is solute. True solution is a mixture that contains small solute substances, sugar and water. Colloidal is a heterogeneous mixture made up of two phases with dispersed phase and dispersion phase.
Yeah, that this you have to read it as namely.
Okay, sir.
That it is written as VAZ, but எப்படி படிக்கணும்னா, the pronunciation is, you have to pronounce it as namely. Okay?
Yes, sir.
I'm sure you know this. Maybe no, you have not used it, but you know this. Yeah.
Okay, sir. Namely, dispersed phase and dispersion phase, that is solvent. Milk liquid in liquid, cheese solid in solid, smoke solid in gas, blood liquid in liquid, soda water gas in liquid.
Yeah.
Suspension is a heterogeneous mixture of small insoluble particles. Chalk powder particles are visible to the naked eye. Tyndall effect, a phenomenon by which colloidal particles scatter light. Brownian motion, a phenomenon of continuous random motion of colloidal particles. Saturated solution, where no more solute can be dissolved, nitrogen in soil. Supersaturated solution, which has more solute at a given temperature than that of a saturated solution.
Okay, so these are some of the things which you already studied in detail. I'm just recalling that. Okay, then let's go to solubility. Solubility is mass of the solute. How do you find the solubility of a particular solution? Mass of the solute divided by mass of the solvent into 100. So that is why I have written as mass of the solute into 100 divided by mass of the solvent. So that will give you a figure that is called solubility. Nature of solute and solvent, temperature and pressure determine the solubility. What will determine the solubility of a solute in solvent is the nature of solute, nature of solvent, temperature and pressure. All the four will decide the solubility of a particular solute in a solvent. Solubility in water. Solubility in water, calcium carbonate, what is the solubility in water is zero point 0, calcium carbonate is written as CoCO3, it is 0.013 gram per 100 gram of water. I think this is for the saturated solution, maybe, solubility. Okay, then sodium chloride, that is, no, solubility percentage is 36. Ammonia, NH3 is ammonia, 48. NaOH, what is this NaOH? Sodium?
Sodium hydroxide.
Yeah, sodium hydroxide, that is 80. Glucose, C6H12. What is that?
C6H12O6.
O6, huh? I think O is missing. Correct? Am I
Yes,
correct?
sir.
O is missing there, no?
Yes, sir.
Mama, correct. Okay, I don't know how to type. Okay. Then NaBr, glucose is 91. NaBr, sodium bromide, probably 95. NaI, sodium iodide, 184. Polar compounds do not dissolve in non-polar solvents such as ether, benzene, alcohol, etc. Non-polar solvent is water is a polar solvent. So polar compounds do not dissolve in non-polar solvents. Which are non-polar solvents? Ether, benzene, alcohol are non-polar solvents, whereas water is a polar solvent. Solubility of solid increases with temperature in endothermic reaction and it decreases in exothermic reaction. Little confusing for me. Solubility of solid increases with temperature. That we know. That when you increase the temperature, you can dissolve more solute. In endothermic reaction, endothermic means that which takes heat inside, that one. It decreases in exothermic reaction. Exothermic reaction is it gives out, it releases heat. So what is the one example of exothermic reaction which we all know? What is that called? In Tamil we call sunnambu. What is that in English?
Sir, calcium
Limestone.
carbonate.
Calcium?
Carbonate.
Yeah, it's called, I think, calcium carbonate. That one, if you put sunnambu, calcium carbonate in water, that releases heat. Am I correct?
Sir, sorry. Calcium hydroxide, if you put in water, will get calcium carbonate. Calcium oxide.
Anyway, you check that because I'm not getting it. I forgot. See, this slide I prepared at least about 2-3 years back, not now. So I forget many things these days. Okay, right. Solubility of gases in liquid decreases with temperature. Solubility of gases in liquid decreases with temperature. Decreases when the temperature increases. That is the meaning. Solubility of gas in liquid increases with pressure. So these are two things very important. Solubility of gases in liquid decreases with temperature. Solubility of gas in liquid increases with pressure. That is the reason why the soda water is the solubility of gas in liquid and it is kept in the pressured can so that the solubility is increased. Okay, that one. Concentration of solution is equal to mass percentage. Concentration of solution is measured that is called mass percentage is equal to mass of solute into 100 divided by mass of solution. Volume percentage, volume of solute into 100 divided by volume of solution. How does the first point, solubility and concentration of solution, is what is the difference between these two? Just see. There again we are talking about mass of solute into 100 we are saying divided by mass of solvent there. It is mass of solvent, whereas here it is mass of solution. The mass of solution is equal to mass of solute plus mass of solvent put together. Understood the point I am making? Hello?
Yes, sir.
Yeah, the mass of concentration of solute, mass percentage is equal to mass of solute into 100 divided by mass of solution. Whereas the solubility, this thing is calculated as mass of solute into 100 divided by mass of solvent. Okay. Can anyone read? Abhinav, can you read the entire slide for the benefit of everybody? Srinidhi, you want to read?
Yes, sir.
Hmm.
Solubility equal to mass of the solute into 100 by mass of the solvent. Nature of the solute and solvent, temperature and pressure determine the solubility. Solubility in water. Calcium carbonate CaCO3 is equal to 0.0013 gram by 100 gram of water.
400 gram of water. Yeah.
NaCl
Yeah, carry on, carry on.
NaCl is equal to 36, NH3 is equal to 48, NaOH is equal to 80, glucose C6H12O6 is equal to 6. Sir, what, sir?
No, this is actually no 69. This is 91. Sorry, what I have written. You get the O6. This is O6. I am not able to write O. O is, I think it comes here. No, I think I have to do something else for that. Okay, so it is C6H12O6.
Is equal
That solubility of glucose is equal to 91. Okay.
Okay, sir. NaBr is equal to 95. NaL is equal to 184.
NaI, I think. The sodium iodide. Sodium iodide. Okay.
Okay. Polar compounds do not dissolve in non-polar solvents such as ether, benzene, alcohol, etc. Vice versa. Solubility of solid increases with temperature in endothermic reaction and it decreases in exothermic reaction. Solubility of gases in liquid decreases with temperature. Solubility of gas in liquid increases with pressure. Concentration of solution is to mass percentage equal to mass of solute by into 100 by mass of solution. Volume percentage equal to volume of solute into 100 by volume of solution.
Very good. So I think it is understood whatever, but the only thing is now you should digest this. You have to go and see, you have to understand it fully because since you have studied 1 or 2 years before, understand it fully so that when it is required, you should be able to recall it. The straight questions will not be there, but somewhere this knowledge will be useful. Okay? Right. Then let us look at atom. Atom is, I think, one chapter in your book. Atom, you know, I think you must have studied somewhere in your small classes. Atom as a nucleus, and you have electrons doing rounds around the nucleus. Okay? In the nucleus, you have proton and neutron. All these things you know. So, atomic number is equal to number of protons, which is equal to number of electrons. The number of electrons you have in an atom is equal to number of protons. Okay? But the mass of the proton will be equal to mass of electron. Can we say that? Number of proton is equal to number of electrons. But is the mass of proton is equal to mass of electron?
No, sir.
No, mass of electron will be very, very small compared to mass of proton. Okay, very good. Protons have positive charge and electrons have negative charge. Neutrons have no charge. So in the nucleus you have protons and neutrons, and protons have positive charge and electrons which is going around, circling around, that is called, which has got negative charge. So you can say a nucleus will have a positive charge and electrons will have negative charge. Nucleus, it includes neutrons and protons. Then mass number is equal to number of protons plus number of neutrons. Again, mass number. It is not in gram or something, not like that. Mass number equal to number of protons plus number of neutrons. Electrons have negligible mass. And these masses are calculated as AMU, atomic mass unit. 1 AMU is equal to 1 by 12 of atomic mass of carbon, carbon 12. Carbon has got many atomic numbers. So carbon 12 and some other number. But here we are taking carbon 12. So 1 by 12 of atomic mass of carbon 12 is called 1 AMU, atomic mass unit. Atomic weights, atomic equal to atomic weight and atomic mass are same. I mean, there's no difference. Hydrogen atomic mass is 1, carbon it is 12, nitrogen atomic mass is 14, oxygen atomic mass or atomic weight, whatever, atomic weight, I think you are more familiar with atomic weight. Atomic weight of oxygen is 16, atomic weight of sodium is 23, atomic weight of magnesium is 24, atomic weight of sulfur is 32, atomic weight of chlorine, that is a gas, 35.5, atomic weight of potassium is 39. What is the symbol for potassium? Symbol for potassium.
K.
Chemical symbol.
K, sir.
K. Very good, very good, very good. So what is the symbol for sodium? What is the symbol for sodium? Na. Na is sodium. Sulfur. Sulfur is just S. Chlorine is Cl. Calcium is Ca. Calcium, atomic weight of calcium is 40. Atomic weight of iron, it is called Fe, that is 56. Atomic weight of copper, Cu, 63.5. Atomic weight of silver, Ag, is 108. Atomic weight of zinc, that is Zn, is equal to 65. When you write the symbol, the first letter will be in capital, the second letter will be in small, not capital, small letters. That is why F is in big letter capital and other E is small. So like that zinc. Okay. Then what do we mean by isotopes? Atoms of same element with same atomic number but with different mass number. So what is the atomic number? It is number of proton. What is mass number? It is number of proton plus number of neutron. So atoms of same element, say atoms of carbon, same element with the same atomic number but with different mass number, those are called isotopes. Isotopes, I think it's there in sulfur, I think. Sulfur, you have got many isotopes, I think. Isobars, atoms of different elements with the same mass number but different atomic number. Those are called isobars. Isotones, atoms of different elements with the same number of neutrons. Atoms is no longer indivisible. In some long years back, they were saying atom is not divisible. But today they are saying atom is divisible, so it's no longer indivisible. Atom is no longer indestructible. Okay, it can be transmuted. It can be divisible also. Atoms may not combine in a single whole number ratio. Atom may not combine in a single whole number ratio. For example, C6H12O12, O2. Sucrose, glucose is it O2 or O6? I don't know. And sucrose is C12H22O17. So that's it. So anybody can read this? One of you? Patil, Sachin, can you read this?
Yes, sir.
Yeah, please.
Atomic number is equal to numbers of protons is equal to numbers of electrons. Protons have positive charge and electrons have negative charge. Neutrons have no charge. Mass number is equal to number of protons plus number of neutrons. Electrons have negligible mass. 1 AMU is equal to 1 by 12 of atomic mass of carbon 12.
Yeah.
Atomic weight is equal to atomic mass. Hydrogen atomic mass number is 1. Carbon atomic mass number is 12. Nitrogen atomic mass number is 14. Oxygen atomic mass number is 16. Sodium atomic mass number is 23.
Yeah. Mg,
Um,
magnesium.
Magnesium's atomic number is 24. Sulfur atomic number is 32. Chlorine atomic number is 35.5. Potassium atomic number is 39. Calcium atomic number is 40. Iron atomic number is 56. Copper atomic number is 63.5. Silver atomic number is 108. Zinc atomic number is 65.
Yeah.
First, atoms of same elements with same atomic number but different mass number.
Isotopes. Those are called isotopes. The next one is isobars. Isobars.
Isobars, atoms of different elements with same mass number but with different atomic number. Isotones, atoms of different elements with same number of neutrons. Atoms is no longer indivisible. Atom is no longer indestructible. Artificial transactions. Atoms may not combine in a single whole number ratio. Glucose, carbon 6, hydrogen 12, oxygen 2, sucrose is equal to carbon 12, hydrogen 22, oxygen 70.
Okay. Anyway, I think that you check, Abhinav, you check that. I'm not very sure. C6, H12, O6 you said. Maybe you are correct. Maybe when I typed it, it must have come wrongly. So we have seen 3 slides. Plenty of slides are there. We will go through one by one. How many slides are there? Sometimes 56. I'm going to send you this PPT to you. I mean, you need not go through all the slides, but you go through the whatever slides we have covered. So if we are covering 3, you just go through 3. Make sure that you have understood everything. If you have any doubts, you raise the doubts in the WhatsApp group or in the next class. Okay. So we'll close at this. I will not be available on Thursday. Thursday there is no class. Again, we will meet next Thursday. Okay. So thank you so much. If you have anything, you can any doubt, you can send your doubts in the WhatsApp group.
Thank you, sir.
I am posting some questions in the WhatsApp group, not necessarily meant for you. It is meant for some junior people also. And even if when I put the question for junior people, 8th standard, still I will send those things to your group also, so that now you can answer. So similarly, when I put some questions for you, if I think that is relevant for junior groups, I put in the junior groups also. Junior group means 8th standard, 7th standard. Okay? Right? So we'll close at this. We'll meet again in the next class. So any doubts, Abhinav, Sharan, Srinidhi? Is there doubt, Rika? You have any doubts?
No, sir.
Okay. In case you have anything, you let me know. No? We will discuss in next class.
Oh.
Okay? Thank you, ma. Thank you.
Thank you, sir.
Thank you. Sachin, what is your name? Your Nega?
Palak Patil.
Oh, Palak Pat. Okay. Your voice is very nice, Palak. Fantastic. I really, it is very sweet and it is little, novel for me, your voice. Okay.